Hello YouTube. Okay, right now I'm filming this video at 1 a.m. in the morning, but I don't get sleep. It's a weekday, so I'll still have school and I'll suffer the consequences in English and biology class, but it doesn't matter to me. So, 2 days ago I made a video on how to differentiate x to the x, but it was a joke video, so obviously I differentiated it incorrectly. So in this video, I'll teach you two ways to differentiate x to the x, and then I'll also teach you guys how to differentiate x to the x to the x, and I'll teach you guys how to differentiate x to the x to the x to the x power. But first, let's start off with the methods to differentiate x to the x. So we have method 1. So method 1 involves, first of all, taking the ln of x to the x and then raising all of that to the e power. And that way this is still equal to x to the x because they're equivalent to each other because e and ln cancels out. So after we get this is equal to e to the x ln x power by logarithm properties because ln a to the n power equals n ln a. So now we got that out of the way, we can differentiate this expression because remember, we're trying to find the derivative. We haven't quite done that yet. So we have derivative of e to the x ln x power, and this is equal to e to the x ln x power. But then we have to chain rule, so we have to take the derivative of what's in the power, which is x ln x. So given that, we can now just apply the product rule to find what's in the chain. That's 1 times ln x plus x over x, or e to the x ln x times ln x plus 1, which is equal to x to the x ln x plus 1. And the reason why I could reduce e to the x ln x to x to the x is because this expression is equal to this. And then e to the ln cancels out, leaving x to the x. So this is the answer. Now let me go over method 2 to solving it. Method 2 involves having the logarithm placed before any of the differentiation. So we'll have y equals x to the x, and then before we do anything, you'll take the ln of everything. So now we have ln of y equals ln of x to the x. This is equal to ln of y equals x ln x. Now, what we're going to do now is take the derivative of everything. So we can differentiate everything with respect to dx. So we'll have this expression works mathematically. And then now what we'll have is we'll have y prime of x over y of x. That's equal to product rule. And the reason why we could do that is because the chain rule tells us that if we have f of g of x, we take the derivative of this, you'll get f prime of g of x equal times g prime of x equals. So our f prime is going to be this here. F prime of g is going to be the y of x on the bottom because the derivative of ln y is 1 over y. Then whatever is on top, y prime is g prime. So anyways, we now have y prime over y equals ln x plus 1. All we have to do now is multiply both sides by y. So now we get y prime equals ln x plus 1 times y. That's equal to ln x plus 1 times x to the x power. Now, take a second to contrast these different methods. They lead to the same answer, and the only difference between them is when I placed ln of x. Here, I didn't need to do all that e to the x stuff because I added ln beforehand and differentiated with respect to ln y. Here, I did all that fancy e ln x stuff and had to do a little more work. But they still lead to the same answer, and it was fairly easy. Now let's move on to problem 2, which is differentiating x to the x to the x. And before we do that, I'm going to keep the answer from problem 1 up here. So problem 1, derivative of x to the x is equal to x to the x times ln x plus 1. We're going to keep that in mind. And now we're going to move on to the next problem, which is taking the derivative of x to the x to the x. So we can use method 2 because method 1 would be too complex to do all that, like e to the ln whatever. So we could just use method 2. So we could set ln of y equal to ln of x to the x to the x. Let me get a new marker that actually works. Then this is equal to ln of y equals x to the x times ln x. Then we can differentiate both sides like usual. We can use a result from problem 1 to use the product rule here. So we'll have x to the x power times ln x plus 1 times ln x, because we differentiate f, because f g's derivative is equal to f prime g plus fg prime. So now we find fg prime. So that's x to the x times 1 over x. So then this derivative is equal to x to the x times ln squared x plus x to the x ln x plus x to the x minus 1 power. But we're not done yet. We still have to multiply both sides by y. So after multiplying y, which is x to the x to the x power, we get x to the x to the x times x to the x ln squared plus x to the x ln x plus x to the x minus 1. And we're pretty much done. You could simplify it out, but too much effort. Now, let me just put that up here on the board. So we have a result for the next problem that we're going to do. X to the x squared. Let me get rid of all this. And now we have to keep both of these results in mind as we go to problem 3, which is x to the x, or differentiating x to the x to the x. Yeah, I don't know why I'm doing this at 1 a.m. in the morning, but it doesn't matter to me. It's kind of fun. So, like usual, we use that method from part 1, part 2. Then we can use properties of logarithms, so x to the x to the x times ln x. Differentiate it, y prime, y equals, well, we can have that expression here. So x to the x to the x times x to the x ln squared x plus x to the x ln x plus x to the x minus 1 times ln x plus x to the x to the x times 1 over x. Then y prime is all this times y, which is x to the x to the x to the x. So we have this times this times this. And then I can simplify it out just a little bit for you guys, but it would be a little bit of a challenge to try to simplify it completely. So let's go. Let's see if this adds here. So x to the x plus 1. No. Plus 1. ln squared x plus x to the x plus 1 ln of x plus x to the x plus 1 minus 1 ln x plus x to the x minus 1. And then you could go figure out the rest of the simplification, but this is the derivative of x to the x power. Thank you for watching. I don't know why you decided to stay for the whole 15 minutes or whatever of the video. I don't know how long I've been recording for. And I'll see you in the next video, if I ever upload again.